Hello, my name is Masheka, and this is my Module 1 presentation, and we're going over Chapter 8 today. So first we have to draw a graph for each following scenario and explain why the graph corresponds with the scenario. We also must label our x-axis and y-axis. So to solve this problem, we must know what graph we're using. We're going to use a plain, simple graph with time and whatever the x, y-axis, so we can just name them. So we also need to know exactly what type of graph fits the scenario. So let's go to our scenarios. And we'll be using this type of graph. So the first one is the amount of gas a tank when a driver fills the tank across the country. So when we think about this, we know how gas goes away and it can be filled up at one spot. So when I think of this, I think that we'll start at just like medium, and then we'll go down. But as we go down, we'll stop get gas, so it'll go up in one spot, and then it'll just keep going down. So our x-axis, which will go horizontal, would be our distance across the country, and our y-axis would be the amount of gas, to the point where it looks like this. Now let's go to our next scenario. Is the height of the elevator stopping at each floor on the way up. Now it says on the way up and it's not going down, which means that it'll just keep going up. So when I think of this, I think of those steps because we'll rest at once for amount of time, and then we'll keep going up, and then we'll rest, which will be a time period, which will go down, and then we'll go up. So I believe the x-axis will be the amount of time, and the y-axis will be these floors, or height. Now we have the height of a bouncing ball dropping from a table. Now this one, when you bounce the ball and we just let it go, we know that the ball don't hit the same position once. It will not hit the same position again. So when we see a bouncing ball, we'll just see with lines because it did not go to the same place at the same time. So our x-axis will be the number of balls, and then our y-axis will be the height of the bounces. And now we have the length of a shadow of flagpole of the length throughout a sunny day. So we know at 6 o'clock we don't see any sun. But we still see a shadow a little bit whenever the sun keeps going up, and it'll be a little arch as it keeps going up through midday. It'll be the highest point, and then whenever midday goes away, it'll go to the other side of the pole. So with this, we'll just see an arch, and it'll look like this. So time of day, the highest point will be midday, and then the length of shadow is our y-axis. Okay, let's go to question 2. Now we have to explain g of x, where x is 0, 1, 2, and 3. Now to solve this, it is pretty simple. We just plug x in with our numbers. Sometimes they won't give us our x value, and we'll just make up our own, which is what I said in here. But they did give us an x, which is 0, 1, 2, 3. So all we had to do was just plug it in for x. And then when we get our f of x, then we'll plug in our numbers again for our g of f of x, which would be adding 8 for our g. And like I'm about to show you. Now to solve this, it will be easy to create a chart so you don't get sidetracked, and then you'll know what goes where. And then we'll also have to graph our slopes. So this is our chart we'll be using. And then the graph we'll be using is the same type of chart. So here go our x column, which is our 0, 1, 2, and 3. Now for our s of x, we have a 3x, which means it's 3 times our x. So we'll just plug in our x for the x. So we have 3 times 0, which is 0, 3 times 1, which is 3, and so on. And then we have our g of f of x, which is f of x plus 8, which means this column plus 8 more. So we have 0 plus 8, which is 8, 3 plus 8, which is 11, and so on. And then our graph looks something like this. Now we have to show and explain the slope of a segment determined by the given pairs of points. And then tell how, basically, in simplified form, We just have to explain our graph and our slopes. So to solve this, I said that it would be easy to use rise over run, which is going up, which is rise over run. And then we simplify it. That's the easiest way. But we also have a formula, which I'm going to show you both ways. So we have our formula we are using, which is y2 minus y1 over s2 minus s1, and that gives us our slope 2. Now we'll be using a coordinate graph for this since we're going to have negative and positive numbers. So our first one, we have P is 3, 1, Q, 5, 5. So I also didn't mention, but we also need to know what is X and what is Y. So our first number in our given points is always going to be X, and our second number is going to be Y. And this is going to actually come in handy in a second problem, in another problem I'm going to show you later on. So then we're going to plot P first. So when it has 3, 1, this is our x-axis, and this is our y-axis. I don't know if you can't see the y, but this is our x-axis. So we have 3 over 1, so our slope is we go over 3, because 3 is in our x-axis, and then we go up 1, so our P will be right here. And then we have Q, which is 5, 5, so we'll go over 5, and then we go up 5, which our point will be right here. And that's a slope. So like I said, you can do rise over run, and it's actually very easy. You just go up how many, and then you get to the same line as the other, and then you go over. So this one we have 4, and then we have 2, and 4 over 2, which will give us 2, so our slope will be 2. Now we also can plug in for our slope form. So we have y2 minus y1, which is 5 and 1. So our y2 will be our q, our y1 will be our 1. So y2, y1, so that is 5 minus 1. And then we have 4, and then we have our 5 over 3, which will be our x's. So we have, again, 4 over 2, or the slope will be 2. Now we can do the same thing. We can do rise over run, or we could do our slope. This is actually very easy. We also gonna you'll use FC. So let's just plot our points first before I get ahead of myself. We have R, which is 5 over 8, 5, 8. So again, over 5, and then up 8. So our point will be right here. And then we have 5, negative 8, so over 5, and over negative 8, so our point will be right here. Now this is an undefined slope because we don't have a slope. Our slope is 0. So it is called an undefined slope. That's what I was trying to say earlier, but I got ahead of myself. But we can, of course, do our slope formula. And this will be 16 over 0. And because 0 is in a denominator, it'll be undefined. Okay, now we have y2 minus y1, again, x2 minus s1. And we have our u, and we have v. Now, of course, this goes to negative 13. So this will actually be an easier way to do the slope formula instead of plotting, since ours goes to 10. Now, what I also did was I added more lines here, and so you can see those points still. So we have our u, which is negative 1, negative 4. So negative 1 goes down 4. It'll be right here. Then we have a v, which is negative 4, negative 13. So negative 4 and then negative 13. So it'll be right here. This was actually 10, but I just made it 13. Oh, sorry. And that goes our slope. Now, like I said, it'll be easy to do the slope form in case like this is hard to calculate. So it'll be easy to use our formula. And we get over negative 9 over negative 3, and our negative will cross out each other, and we'll get a positive 3 as our slope. Now, our next question, question 4. Show and explain the graph of each following function and describes the similarities and differences between relationships. So we have x2, x to the power of 2, x to the power of 2 plus 7, x to the power of 2 of negative 7. Now, this is actually a cool graph because it's not going to be like the other graphs that we have. With our x to the power of 2, we're actually going to get a U-shaped graph. Oh, okay. Sorry about that. So we're actually going to get a U-shaped graph. So with this being said, that if our graph is not going to look the same, of course, like others. Our graph is actually going to look like this. Now to solve this, we actually had to look at our second number. Now our y, this don't have a second number, which means our y going to be 0, because our second number determines our y-axis. So we have no number right here, which means it's going to be 0. So our first is actually going to be like this graph, going to be placed at 0. And then we have our second number, which is +7, which means it's going to go up 7 and down 7 for the C. So our graph is actually going to look like this. So let's plot x2, like I said. It's going to be our origin, which is 0. And then we have +7, it'll go up 7. And then we have -7, it'll go down 7. And that didn't actually trust the graph. I'm sorry, I plotted this myself. So now we have to compare the graphs. Now comparing the graphs, they all look the same. The only difference I see is that it just moves up and down the y-axis, which is what our +7 and -7 is supposed to mean. So that's our difference between our graphs. Now let's go to question 5. Now we have to find the perpendicular slope to the slope that's given to us. So we got two slopes here, and we had to find perpendicular. So in case for the ones who don't know, a perpendicular slope is what it will go the opposite direction, and it will only be the same plot at one point. It will cross paths at one point, and then they will never touch again. That is a perpendicular slope. Now we have our slopes. We also have to solve our slopes in case it's not given to us in the right form, like it's question B, and we'll get to that in a minute. And of course, this is what all I just said. Now here go our slope formula. Our slope formula is so we will know what goes where. And I'm going to show you that again in the next slide. And this is our graph we'll be using. Now, like I said, I'll show you in the next slide. Now, our slope formula is very important because we need to know what goes where. R is our given point. This is what's given to us in a problem. Then y equals -3/4x. This is our slope. So notice this, the x is always with the slope. That's how I always remember it. And then we have our y-intercept, which is, of course, like our last problem, which is away from the rest of the problem. Now, our y-intercept, this is where our point would be on a y-intercept, on a y-section, on a y-axis, sorry. So this is how we'll know. So now we have to solve with the point formula, which is y equals -1 equals m, which is our slope, this is m, over x minus x1. So our perpendicular form, we'll plug it in. Oops, sorry, I went ahead of myself. So let's just plug in. Our y is our -1, which would be y equals -1. Of course, this will simplify to +1 because two negatives will make a positive. And then our perpendicular, we're finding perpendicular, so which means we have to take the opposite of our slope. So this means we'll have a 4/3, and it'll be positive because we'll get rid of the negatives because it is a perpendicular. And then we have our x, which are assists. You can get this by the given point. So we'll have y plus 1 equals 4/3 x minus 6. So now we'll just distribute the 4/3 into the to x minus 6. And this will get us 4/3 x minus 24/3, or 8. This simplifies to 8. And then we have our y plus 1 left. So we'll just subtract 1 and then subtract 1 on both sides, which will give us, sorry, I just explained that, -4/3 plus 9. And now we'll just plug it in with just random numbers. Like I said, on the first one, it'll be easier to just do smaller numbers or go to bigger numbers. So we'll just see the graph itself. So we have -5, -4, -3, -2, and so on. And then we'll just plug it into our given section. And then this is our perpendicular slope, and this is our regular slope that is given to us. So we plug this number into this slope, and then we plug this number into this slope. And then our graph will look like this. Oh, and of course, it intersects at one section. You can't see it because I zoomed out. And also because I zoomed out, you won't see that this is actually a right angle. But yeah, sorry about that. And now we have our other slope. Now, of course, this is not like the other equation of a line because this is not solved. So we had to put this in simplest form. And to do this in simplest form, we had to get y by itself. So now we had to solve our regular slope first. To solve it, we had to get y by ourselves, which means we had to subtract 9x and then plus 5 because this is a negative, so we had to plus 5. And now that we have this all on the other side, now we have to divide everything by 2 to get y by itself. And our slope will be negative 9 over 2 plus 5 over 2. And of course, now we do what we did in our last problem or our last example and find the perpendicular slope. Now we just do our perpendicular slope, which is y minus y1 equals mx plus 3. Of course, the one with the x is our slope, which is right here. Our y, which is here. And then we just keep plugging in. So when we got our things figured out, we'll just distribute the 9 over 2, which will be 9 over x. And then this is a 0, which means this will just cancel out. And now that we have the 9 over x, we'll just plus 3 to get everything by itself, y by itself. And this will be our perpendicular slope. And now we make a chart and we plug in our numbers. So of course I did negative 9 to positive 5. And then I just plug it into our regular slope. And then I plug it into our perpendicular slope. And then our graph looks like this. Okay, I'm sorry, I had to make sure I was recording. And now we have our last question, which is question 6. We have to show the equation of a line that is a tangent to the circle radius of 9 or at 9, which is our, 0, negative 9, and 0, 9. So circle is very important because we know circle is even on all sides. So it's actually easy. We don't need a slope for this one. There is a slope for this one. But because this is actually easy, I'm not going to show you the slope. I'm not going to show you the hard way since this is actually easy. And when it's a circle, it's actually easy for everything when it's a circle. So first we need to know what the origin is, which is at the middle of our graph, which is like I show right here. Our origin is 0, 0, is at point 0, 0. Now to solve this, it'll be easy to actually plot our two numbers, our 2 points, which is 0, negative 9 and 0, 9. Also, we also need to know what a tangent is. Tangent means on the side of our point. So because of circle, like I said, circle is important. So of course, we need to know what the origin is, which is the circle, which I highlighted again right here. Now we just need to plot our points. Like I said, it'll be easy to plot the point. Now it's a circle, which is circle is very important. So let's just draw a circle. Now when we draw a circle and at a radius of 9, it'll be easy to find a tangent by just switching our two numbers around. So switching our x and y axis around. So it'll be negative 9, 0, and positive 9, 0. And that is actually our tangent lines. That's why it's important that it's a circle because it's actually easier. And like I said, tangent, you'll see circle, it just touches the end of the circle. And that's your radius of 9. So now they want us to compare our new lines. So of course, when we compare our new lines to our old lines, we see that they're perpendicular, which is what we dealt with in the last problem or other problems. I think it was 2 problems ago. And now if we compare them to each other, we'll see that they're parallel, which means they will never intersect at each other. So they'll never intersect. But unlike our new line and our old line, they intersect at 9 and negative 9. This is where they intersect at. But with our new lines, they will never intersect each other, which means they're parallel. And I believe that is our last question. Thank you for watching my solo presentation. Hope you have a nice day.